Good morning, my dear students. My first lesson in calculus, inshallah, is the L'Hopital's rule. The L'Hopital's rule states that if the limit as x approaches c of f of x over g of x is equal to one of the indeterminate forms, 0 over 0, or positive infinity over positive infinity, or negative infinity over positive infinity, or positive infinity over negative infinity, we should know that by using the derivative you can get something useful. You can find your answer quickly and easily. Let's see one example here, how to use L'Hopital's rule to find the limit or to find the value of a limit. Let's take the first example here. Example 1. Find the limit as x approaches 0 of x squared over sine x. First of all, when you see a limit and the question asking you for finding the value of a limit, you use direct substitution. I know that you know this step. Let's here apply the substitution way. 0 squared, which is 0, over sine 0. All of us know it's 0. Nice. But this one is called indeterminate form, and we should find the value of this limit by multiplying by something like conjugate, long division, factoring. Anyway, you have studied algebraic way to find the value of this limit. But here, L'Hopital's way or rule can help us to use derivatives to find the limit. I think that we used the definition of limit to evaluate the derivative, right? But here in this lesson we're gonna use derivatives to evaluate the limits. So simply you write here the first step in your answer, the limit as x approaches 0, and the derivative of 2x, which is the derivative of x squared is 2x, and the derivative of sine x is what? Is cosine x. Excellent. And then direct substitution. Try to substitute 0 for x, 2 times 0, which is 0, and cosine 0 here. Yes, it's 1. Nice. So your answer, is it indeterminate form? No, it's here 0. So this is the L'Hopital's rule. You should use the derivative of the top and the derivative of the bottom once a time, or you can use it several times until you get something useful like 0, like any number. Okay. So here, guys, way to remember, differentiate top and bottom until you get something useful, you get a number. Example 2. Find the limit as x approaches. Find the limit as x approaches negative infinity of 3x minus 2 over e to the power of x squared. Direct substitution. Negative infinity for x, multiplying 3 by negative infinity gonna give us a negative big number, minus 2, which is negative big number, minus 2 is negative infinity, over e to the power of negative infinity squared. E to the power of negative infinity squared gonna give us e to the power of infinity, which is a very, very, very large number, and dividing negative infinity by positive infinity also is what? Indeterminate form. So what should we do here? Let's apply the L'Hopital's rule, our lesson today. L'Hopital's rule gonna help us to find the value of this limit easily and quickly. The limit as x approaches negative infinity is, find the derivative of the numerator. The top here is 3x minus 2. So what's the derivative of 3x? Yes, good, it's a 3. What's the derivative of 2? 0, because 2 is a constant. What's the derivative of the denominator, the bottom here? Is e to the power of x squared. What's the derivative? Yeah, the derivative is the same, e to the power of x squared, listen, and then multiply by the derivative of the exponent times the derivative of x squared, which is 2x. Excellent. Now apply the substitution again. Substitute negative infinity. The numerator will be 3 over negative infinity times 2 is negative big number, negative infinity, and the e to the power of positive infinity gonna give us large what? Negative number. Large negative number. Why? Because 2 times negative infinity is a negative infinity, times e to the power of infinity, which is a positive infinity, times negative infinity, gonna give us a large negative number, and dividing 3 by a large negative number, I think it's what? 0. Okay, which is what? 0. We have common mistakes. We should avoid these common mistakes, and here are 2 common mistakes we should avoid. L'Hopital's rule should not be used if the limit is not indeterminate form, indeterminate type. For example, the following limit is not indeterminate. In fact, the substitution rule applies to give the limit, like this one. The limit as x approaches 0 of sine x over x plus 1. When you apply the substitution, substitute 0 for x. Sine 0 is 0 over 0 plus 1, which is 1. And 0 over 1 is 0. It's not indeterminate form. So it's wrong here to use my L'Hopital. It's not useful to use or apply the L'Hopital's rule. If we try to apply the L'Hopital's rule, when I have an answer is not indeterminate form, so the answer here by applying the L'Hopital rule is the limit as x approaches 0 of the derivative of sine x, which is cosine x, over the derivative of x here is 1, and substitution 0 for x, substitute 0 for x. Cosine 0 is 1 over 1 now, because it's constant, 1 over 1, which is 1. Now we have 2 different answers. So the first common mistake, don't use the L'Hopital's rule when your answer from the beginning is not indeterminate form, 0 over 0, positive infinity over positive infinity. This is the first common mistake. Okay, and also the second common mistake here, the second common mistake we should avoid. We know that although L'Hopital's rule involves a quotient f of x over g of x as well as derivatives, the quotient rule of differentiation we have studied in the first term is not involved. Okay, because in the L'Hopital's rule we're gonna find f prime of x separately and g prime of x, but don't do this, don't do this. F of x over g of x, and then deal with the fraction as f of x over g of x and find the prime of the whole fraction by using the quotient rule. This is the second common mistake, and all of us know what is the quotient rule, which is g prime of x, then g prime times f g of x, times f prime of x minus the numerator, which is f of x times the derivative of the denominator. Don't apply this one, don't apply the quotient rule. We just find the derivative of the numerators and then the derivative of the bottom, the denominator, separately. Don't find and don't use the quotient rule. Okay, don't use the quotient rule. One more example here, one more example. Example number 3. Example number 3. Find the limit as x approaches 0 of sine x over x. Who can solve this question, guys? I'm gonna give you 1 minute to think, and then we will solve it together. Here you are. Okay, guys, I think it's less than 1 minute, but let's hear direct substitution. I know that you did, all of you, this step, which is sine 0, which is 0, right, over 0, indeterminate form. So here we can use we can use the L'Hopital's rule to find quickly the value of this limit. The limit as x approaches 0 of the derivative of sine is cosine x, and the derivative of x is 1 on direct substitution. So now the direct substitution, cosine 0 is 1 over 1, and your answer is 1. So easy question, right? Easy question. One more question number 4, example number 4. The limit, find طبعا the limit as x approaches infinity of 3x squared plus x plus 4, and this all over 5x squared plus 8x. Quickly, direct substitution, 3x squared, apply the substitution way first, direct substitution. Infinity squared is infinity times 3 plus infinity plus 4, it's infinity, because it's a very large number, over 5 times positive infinity squared plus 5, all of this will be positive what? Positive infinity, and this called indeterminate form. Okay, how to find your answer quickly? The L'Hopital's rule states that if we have f of x over g of x, and the question asking you to find the limit of this quotient as x approaches the 0 or positive, negative, infinity, or anything else, we will apply the L'Hopital's rule. Find the derivative of the numerator, the limit as x approaches infinity of 3x squared plus x plus 4. Find the derivative d over dx of the numerator separately, and then find again the derivative of the bottom here, the denominator, 5x squared plus 8x. What's the answer? Yeah, we're gonna get here the derivative of 3x squared is 6x, right? Drop down the exponent and multiply it by the coefficient 3 and subtract 1 from the exponent as you have studied in the first term, and the derivative of x, which is 1, plus the derivative of any constant is 0, over the derivative of 5x squared. The derivative of 5x squared is, yes, 10x, excellent, plus the derivative of 8x is 8. Then try to substitute again. Infinity times 6 is infinity plus 1, which is infinity, right? It's a very large number, plus 1 gonna give us a very large number, right? Over 10 times infinity is infinity plus 8, also infinity, so the same answer, which is positive infinity over positive infinity. Can we apply the L'Hopital's rule again for one more time? Yes, we can apply the L'Hopital's rule for many times until you get something useful. I said for you, the way to remember here is to differentiate up, top, and bottom until you get something useful, until you get the answer. So what's the L'Hopital's rule for the next time? The L'Hopital's rule again. The L'Hopital's rule will be the limit as x approaches infinity of, what's the derivative of 6x? It's 6, over the derivative of 10x, which is 10, and we know that the derivative of 1 and 8 are zeros. So 6 over 10, and then apply the substitution way, the answer will be 6 over 10. And you can simplify your answer by dividing by 2 both numerator and denominator. You're gonna get 3 over 5. So your answer is 3 over 5. So here in this question, I think that we got the idea that we can use the L'Hopital's rule more than one time. Okay, next slide. Find the value of this limit, and here another indeterminate form, which is infinity times 0. Pay attention in this example. It's example number 4 or 5, I think. I think that it's example number, yes, 5. Example number 5. The limit as x approaches 0, sorry, as x approaches infinity of xe to the power of negative x times, sorry, yeah, like this only. This is the question here. Yes. Here's the question. Find the value of the limit as x approaches positive infinity of x times e to the power of negative x. Okay. To find the value of this limit, we will use direct substitution, which is infinity for x and e to the power of negative infinity, and this all will be infinity, and e to the power of negative infinity is what? 0. This type is called indeterminate form. Infinity times 0 cannot be determined by using inspection. The first factor going to be infinity, okay, is trying to make the expression large, while the second factor going to be 0 is trying to make the expression small. There is a struggle going on here. Like infinity will make this expression very, very large, and then 0, the second factor, which is trying to make the expression very, very small. Okay, we say that this limit is indeterminate form of the type of infinity times 0. And the strategy here, guys, is to use your L'Hopital's rule. To rewrite first this product as a quotient and then use the L'Hopital's rule. Yes, this is the trick here in this question. So before we use my L'Hopital's rule is to change the form. Rewrite this expression as x over e to the power of x. Yes, you know طبعا the properties of exponents that when you have a negative exponent you can write your answer as a positive exponent by changing its position from the numerator and write it in the denominator. So the limit as x approaches positive infinity of x over e to the power of x. Easy? Easy. Then apply the L'Hopital's rule. The L'Hopital's here like this mean I will use the L'Hopital's rule. What's the derivative of the numerator? The limit as x approaches positive infinity of the derivative of the numerator, which is guys think it's 1, nice, over the derivative of, what's the derivative of e to the power of x is e to the power of x, and also the integrate of e to the power of x will stay the same, 1 over e to the power of x, and we know 1 over e to the power of infinity, 1 over a very, very, very large positive number. E is a number, so 1 over 2.781 and so on to the power of infinity gonna give us 0.00, which is approaches 0. Okay. I hope you understand everything, guys. We talk here in this video 5 examples, and I hope you got the idea of L'Hopital's rule. We have more examples. We will see this in the next video. So if you have any question, don't hesitate, guys, to contact us and ask us about anything you want. Okay, thank you guys. Goodbye.